Coming to the today's discussion, we can see what is hardness test and what is hardness measurement principle and what are the different hardness methods of measuring hardness. That is Brinell hardness test, Rockwell hardness test, Vickers hardness test, and what are the advantages and limitations with applications. Measurement of hardness, its principle. Hardness is defined as the resistance to penetration. So, based on the metallurgist, so metallurgist is nothing but they are the persons who are studying about the metals. So, they define hardness as a resistance to penetration. Mineralogist is nothing but they deal with minerals. Minerals, it may be any minerals. They define the hardness as it is the resistance to scratching. So metallurgist, they have another definition also. It is the resistance to machining. So generally hardness is nothing but it is the resistance to offered by any material to avoid penetration. Hardness measurement principle. So consider this mechanism. This mechanism is used to apply the load on the workpiece for measuring the hardness. So here you have a lever. Here it is fulcrum. Fulcrum is nothing but it's a hinged point. So based on this, you have a long loading arm. Here you are having a timing mechanism, and here you have a load adding mechanism. So once you add the load here, what happens? This load will pull this lever down. Here you have the timing mechanisms. Here you have the fulcrum. So due to this fixed moment and also the load acting here, this indenter will apply the definite this load on the workpiece or the specimen. So what happens? The impression or the indentation is formed on the surface. After some time, you can release the load. This indenter goes back to the original position. So the hardness is the load applied on a material and then the magnitude of the indentation is taken as the measure of hardness. Consider rubber and steel. If you apply some indentation over rubber and steel, definitely rubber will have the more indentation. So in that case, you can tell the indentation is more. So you can tell the rubber is a softer material. Generally, the good hardness reflects the scratch and wear resistance of the material. Coming to the hardness test types, there are different hardness tests available in the materials world. One is Brinell hardness test, Rockwell hardness test, Vickers hardness test, Shore hardness test, Moe hardness test, and Knoop's hardness test. So all these tests are available to measure the hardness based on the material type, material thickness, and material properties. These methods are useful. So in the previous thing we have studied about the different types of hardness test available. So in the hardness test, what you are doing, you are using the indenter to apply the load on the workpiece. So here you have different types of indenter. Take in the case of a Brinell hardness test, you have the tungsten carbide ball type of indenter. In Vickers test, you have the diamond pyramid type indenter with the diamond angle of 136 degrees. Similarly, Knoop hardness test have the indenter of diamond pyramid, and Rockwell hardness test have the indenter of the shape of diamond cone. That is diamond cone with the angle of 120 degree is used for the indenter in Rockwell hardness mechanism. Coming to the Brinell hardness test, this test is developed by Brinell in 1800s. He is a Swedish engineer. He controlled the quality of the hardness of the steel. So how he measured the hardness of the railway bearing by making some indentation and measuring the technique. So he developed the idea in 1800s, but his idea got into amendment only in 1900s. So the Brinell hardness test leaves a relatively large impression using the tungsten carbide ball. This we can tell it as HBW. That is HB is hardness in Brinell. W is nothing but it is wolfram, chemical name for a tungsten. It gives a large impression on the surface. Similarly, we can go for HBS system also. HBS system is nothing but we can replace the tungsten ball with a steel ball. So that is nothing but hardness in Brinell of steel. Coming to the Brinell hardness, this test is used to calculate the Brinell hardness. This machine uses the tungsten carbide ball or steel ball which is pressed into the specimen and the indentation is marked. This indentator material may be either a tungsten carbide or maybe steel. The indenter size is either it may be 1 mm, 2.5 mm, 5 mm or 10 mm. Based on the thickness of the material we can select it. Similarly, the load, on what load we can apply the indenter, that is 1 kg to 3000 kgf. The maximum hardness you can find using the Brinell hardness is 650 HBW. That is the maximum hardness. If HB is 650 HBW and 650 HBS means 650 HBW is harder because the W is tungsten carbide indenter. It is used for materials with coarse or inhomogeneous grain structure. Similarly, this Brinell hardness is used for larger samples. It is also suitable for forging, casting, where structural elements are large. Coming to the hardness measurement principle, Brinell hardness test is used to measure the hardness on metals as per ASTM E10, ISO 6506 and JS Z2243 standard. It was the first standardized testing process which involves pressing a tungsten carbide ball indenter into the surface of the test material over the time with constant applied load. The frequency for force is in the range of 500 kgf to 3000 kgf. If it is non-ferrous metals, the load range is 500 kgf. If it is ferrous metals, it is the load range of 3000 kgf. The indentation formed on the material is measured with microscope. So the material is softer, the indentation is equal to the indenter diameter. The smaller the indentation, we can tell the harder is the material. So this hardness value is calculated using the equation BHN is equal to 2P divided by pi d into d minus root of d square minus d square. So the P stands for load applied in kilograms. Capital D stands for diameter of indenter and small d stands for diameter of indentation, that is impression formed on the workpiece surface. So coming to the test specimen preparation. So before going to the test, we want to prepare the specimen. So what are all the preparations we want to do before going for the Brinell test? One is the surface should be prepared. Surface means we want to clean the surface and also the surface should be very smooth for measuring the Brinell hardness test. So the surface should be machined. Either it should be machined or should be grinded or should have the lapped operation or polished operation performed on the surface. Lapping and polishing is nothing but it is a finishing operation performed to improve the surface of the material. Similarly, the loads. What are the loads applied? Load is applied in the range of, we already discussed previously, it is in the range of 500 kgf to 3000 kgf. So 500 kgf is the case we form for non-ferrous metal and ferrous metal we have the for 3000 kgf. Based on the ISO standard also we can select the load range from 9.8 Newton to 29,490 Newton. The indentation time is ranging from 10 to 15 seconds. So after 15 seconds we can remove the load and the indentation will be formed. We can have the measurement and we can go for the Brinell hardness number calculation. So the sample thickness in ASTM is 10 times of the indentation depth. Suppose the indentation depth is 10 mm. The sample thickness we want to use as per the ASTM is 10 times of the indentation depth. Similarly, based on the ISO it is 8 times of the indentation depth. So coming to the Brinell hardness test, so these are the procedures. So you have the ball indenter. So over the ball indenter, you are applying the test force. It is in Newton. this indenter will form the indentation of the surface. This indentation of the surface is measured, diameter is measured, and based on the diameter of the indenter and also the indentation in form, you can calculate the BHL. So there are different hardness test methods in Brinell test. One is you can have the different subgroups, that is HB30, HB10, HB5 and HB2.5. That is nothing but it is used for different group of metals. So each subgroup has the same force and diameter ratio. The measured Brinell hardness can be compared with individual subgroups. So in here HBW means HBW slash 187.5, that is nothing but it is Brinell hardness tungsten carbide indenter with 2.5 mm diameter and with a load of 187.5 kgf. Similarly, HBW 750 means W indicates it is a tungsten indicator, tungsten carbide indenter. HB means hardness in Brinell. 5 indicates the diameter of the indenter, and 750 slash 750 indicates the load of the indenter used. So there are different types of Brinell hardness test available in the market. So one is manual, micro hardness testing machine, and semi-automatic and fully automatic testing machine. Fully automatic universal hardness testing machine, semi-automatic universal hardness tester, semi-automatic and fully automatic universal hardness tester, and dedicated single task Brinell hardness testing machine. So there are different types of hardness tests available in the market. So coming to the merits and demerits of the Brinell hardness. So the advantages of Brinell hardness is we can measure the hardness on the rough surface also. The disadvantage is the sample preparation, because the sample preparation needs more time, and also the time in measuring the optical measurement. We cannot getting the direct reading. So you are making some calculations. So based on this hardness test is having some demerits. So since it is a destructive test, you are you are applying the indentation on the surface, and you are having some mark on the surface. So that's why this Brinell hardness test is classified as a destructive test. And also this test is one of the slowest process. It is a time consuming process, because you are applying the load for certain time and removing it, and you take the material and you are using the microscope, you measure the diameter of the indentation, then you apply the formula and you get the result. So since this is the longest process, we can tell this method is the time consuming